Yeah, so we're going to see how that goes. So the particle moves along the x-axis with the velocity given by this from time 0 to 12. The particle is at position x equals -2 at time equals 0. Isn't that silly of me? I use t and x. Kind of, yeah, that would be a bad mistake right there, huh? But we're just going to pretend like those variables are the same. The question is, determine when the particle changes direction from 0 to 12. Can you tell me, what are we even looking for when it changes direction? Look for velocity to change sign. Now what are you going to do? Some people said some good things. You would want to write that on the AP exam. You would. Because they will actually say justify your answer. So you're going to look for where it changes sign. So now what? I don't have two things. I have one thing, but I'll take that one thing and I will set it equal to 0. Good. So 0 equals 2 roots of x minus 6. Sure, 2 roots of t minus 6. Then what are you going to do? Add 6, so 6 equals 2 roots of x. Divide by 2. So 3 equals the root of x, so x is 9. So you found out that at time 9, the velocity is 0. That doesn't mean it necessarily changed sign. In order to see the actual, you need to see the graph. Do you know what the graph of that looks like? What does a square root function look like? Yeah, so it would be very easy for you to simply at this point be able to produce a graph that is shifted down how many units? 6 units, so -6. That goes through +9, and you just produce a graph like that. So we could say v of t changes from what to what? From negative to positive at time equals 9. Excellent answer to that question. When we're determining when it changes direction, we are looking for the velocity changes sign. Finding out where the velocity is 0 helps figure out this spot, but you actually need to look at the graph. Any question? Not too complicated, right? But obviously not something we necessarily are going to remember right off the top of our heads. Determine the distance, the total distance the particle travels from 0 to 9. So the distance the particle travels from 0 to 9. How do I determine distance? The integral of the absolute value of, of v of t dt. From what to what? 0 to 9. So I'm going to take the antiderivative of that. What is the antiderivative of 2 roots of x? 2x to the 3/2 divided by 3/2 or multiplied by, so it'd be 4 over 3, right? Good. And then the antiderivative of -6. Okay. And I evaluate that at 9 and 0. Obviously, when we plug in 0 in this situation, we're going to get. So we plug in 9. Let's see how we deal with this. 9 to the 3/2. You can either cube 9 or you can take the square root of 9. What's the square root of 9? 3 cubed, 27. Divided by 3, 9 times 4, 36. So you get 36 minus 54. And remember, we're going to take the absolute value of that because we have the absolute value of the integral. And so we get the absolute value of -18, which is 18 units. Travels 18 units. Sure, meters, there's no label here, but you could just say 18 meters. Yep. Okay. They want to see the integral at the absolute value piece. Find the position. How do we determine position? Start plus displacement. What is the start? Start is -2. So I have -2 plus the integral from 0 to 4 of v of t dt. So it would be -2 plus, we've already found the antiderivative, haven't we? So we're just going to go 4x to the 3 halves over 3 minus 6x evaluated at 4 and 0. Let's plug in 4, square root of 4, 2 to the 3rd, 8 times 4, so 32 over 3, minus what? 24, otherwise known as 72 over 3. 32 over 3 minus 72 over 3. Negative 40, so -2 plus -40 over 3. Or -6 over 3 minus 40 over 3 is -46 over 3. That's its current location. Is that further to the left from -2 or further to the right? It's further to the left. Does it make sense that it would be further to the left? Because the velocity right here, is it positive or negative? It's negative, so that means the particle is traveling to the left. Okay, so the particle is traveling to the left because the velocity is negative. It's below the x-axis, so it's traveling that way. So we should get something to the further that way. Good. All right. Average velocity. Thoughts? Did it yesterday? 1/9 integral 0 to 9 of v of t dt. Good. Did we already figure out the integral of v of t dt? What was it? It was -18, wasn't it? Yeah. Oh yeah, we'll put that label, so that'll be meters per second to determine velocity. How is average acceleration going to be different? The slope. So we do v of 4 minus v of 1 over 4 minus 1. Where do you plug that 4 in? Yeah, so if you plug in 4, you get -2 minus -4 over 3. So you get 2/3. What is the label? Is per second squared.
What will the label be for the position or label?
Meters. Okay, this is one that I think everybody could get. I'm going to give you 20 seconds to talk on your own about how to set up. Find the acceleration of the particle at time equals 4. Talk to your peer. Acceleration of the particle at time equals 4. Go. Five, four, three, two, one. What do you have to do in order to find the acceleration? Derivative. Notice they have a nice function to find the derivative of. What is the derivative of 2 roots of x? 1 over the root of x or 1 over the root of t. And what's the derivative of -6? 0, right? So if we want to find the acceleration at that time, you would say a of 4, acceleration at 4 is equal to 1 over the root of 4 which is 1/2 meters per second squared. So now I'm going to give you about 1 minute and 20 seconds to do this one entirely on your own. You're almost there. Talk about with your partner. Is the particle speeding up or slowing down at time equals 4? Justify your answer. We did it yesterday. See if you can talk and work through it. We're going to talk to Miss Marissa. No. When we take square root, we say that the principal root is our solution, which is the positive. If it was t squared equals 4, that means there's 2 solutions. So then we list plus or negative 2. Five, four, three, two, one. In order to answer this question, you need to determine the acceleration at time equals 4, which we already have. It's 1/2. You need to determine the velocity at time 4, which is simply just plugging in 4 to the function. And if you plug in 4 to the velocity function, you get negative 2. So does that mean it's speeding up or slowing down? Slowing down. Because V of 4 and A of 4 are opposite signs. If they're the same signs, it's speeding up. If it's opposite sign, it's slowing down. So I want you to appreciate that. Does it help to review this?
Yes.
But at the same time, have we seen elements throughout the year where we prepared for this?
Yes.
Yeah, so we try to introduce it in stages to help you for this moment. Excellent job. Flip it over, and here you go. Snow accumulation. How do you feel about snow right now? Okay. Good news is, so today, we got about 37, a little bit of wind, but tomorrow's supposed to be sunny and 45, and then we're looking at 50s, 60s, and forecast for next Tuesday. Track people, when we host the junior high meet, it's supposed to be 73 outside. So, yeah. So golf is going to be ready to get on the course. Tennis is going to be ready to go. Baseball's going to be ready to go. Softball's already in swing. So get that swing. Softball's already in swing. I guess that would have worked with golf too, huh? Pickleball courts are dry. So get outside and enjoy it, okay? Okay, so we've looked at a couple problems. We looked at the area and volume one, super common, and we looked at the whole particle moving, very common one on the AP exam. I would say that this is the third most common type of problem. I don't know if I've ever seen a set of problems on the AP exam where this type of stuff is not used. The difference is instead of being given a function, you're given a table with values. Have we seen tables with values before during the year? So, but without a doubt, the questions seem to kind of strike people a little bit more challenging, but we want to prepare for this. This is setting us up to a type of AP practice that we're going to do later on. So it says that this is the number of hours that have gone by, and then these are the rates at which the snow is falling. Okay? These are the rates at which the snow is falling. Okay? And it says snow is accumulating from time 0 to time 8, given by that. Actually, it's not falling, it's accumulating, so not even considering melting and everything else. Measured in inches per hour, and t is measured in hours. It is a differentiable function. It says selected values are shown, and at time equals 0, there's currently 2 inches of snow that are currently on the ground. What I want you to do is talk with your peer and decide for letter A, is there a time between 0 and 8 when the snow is accumulating at exactly 2 inches per hour? Justify your answer. Talk. Go. Five, four, three, two, one. Okay. Is there a time where the snow must be falling at a rate of 2? Yes or no? There is. Now, you're right, but you're not going to get the question right on the test unless you're able to justify your answer. Why? Somebody help me down that path. You see that if you're going to go from 1 to 3, you have to cross over 2. And if you're going to go from 3 to 1/4, you have to cross over. So we'll just pick one of those. And we will say that R of 0, okay, is less than 2, which is less than R of 1, okay? So we can already say that within the first hour, it has to cross over 2, okay? But there's something else that we're missing here, and it's in this piece. When it says it's a differentiable function, what does it mean to be differentiable? You're able to take the derivative. And if you're able to take a derivative, that means the function can be drawn without picking up the pencil. What does it mean if you can draw it without picking up the pencil? It is continuous. And when things are continuous, there's a certain theorem that applies. 3 letters. No. IVT. The intermediate value theorem says that if you're going to go from 1 and you're going to go to 3, you got to cross over every single real number in between that. Remember? Okay, it's way back a while ago, isn't it? But intermediate value theorem. So, yes, I've stated right there, the IVT guarantees R of t equal to 2. So intermediate value theorem is an important one to invoke. Okay? And when you see this, it's simply asking, does the function cross over that value? Now, this one is slightly different. Is there a time from 0 to 8 where the derivative, what did you say? MVT, meaning the mean value theorem, right? That's when is the slope equal to that. See if you can look at these boxes and see if you can come up with a time where the slope is equal to a half. Look at the boxes. See if you can find 2 spots where the slope is a half. Try to find it. Go. Try to find it. It's staring right at you. If it was a snake, it'd bite you. Giving you some help. Five, four, three, two, one. It's going to be these two right here. Because, so here's what you have to write. You need to write R of 3 minus what? R of 1 over 3 minus 1. That's the same as, what is R of 3? 4 minus 3 over 2, which is 1 over 2. So we've shown that there's a rate equal to a half. So the MVT guarantees R prime of t equal to a half. You good? Okay. Estimate R prime of t. Are we given R prime of t or R of t? R of t. So we want to estimate the derivative. When we're estimating a derivative, what do we use? Okay, good idea. That's when we're going to estimate the integral. So we're going to do that later. But when we're estimating a derivative, we use slope. Slope is the estimate of the derivative. So it says estimate r prime of t over that. So here's what I want you to do, okay? I want you to just look at this data right here. Actually, no, let's not do it that way. Let's just do the slope. We'll have you think about a different one. So it's r of 8 minus r of 0 over 8 minus 0. Estimated derivative, use slope, okay? What is r of 8? 1/4 minus 1 over 8. What's 1/4 minus 1? Negative 3/4 divided by 8. Negative 3 30-seconds. And we're going to put a label on it. It's the derivative of the rate. So we have inches per hour squared. Now we're going to go to Patty's point where it says use a trapezoidal sum with 4 subintervals to approximate the total snow accumulation from 0 to 8. Do you remember when we did trapezoidal and left hand and right hand stuff? Good. So this is the this is kind of the left is going to be easy. Do you guys want to start with the easy ones, or you just want to get trapezoid out of the way? So let's get trapezoid out of the way. So when I get trapezoidal sum, notice how you have 1, 2, 3, 4 spots. Notice how these are not the same widths. So the way that we used to do it, we really don't want to do that anymore. We need to create trapezoids. And so this is what I have students do. I've struggled with how to teach people to do this best, but last year they feel like they got it the best. So I'm going to draw a trapezoid each time. Okay? Okay? The bottom is the width. So what's the width of this one? 1. What's the width of this one? 2, 3, 2. Okay? The sides of the trapezoids are the heights. It doesn't matter. You can put 1 here, 3 there. It doesn't matter. We've just drawn a figure to help us out. But so I put 1 and 3 there. And then I put 3 and 4. Then I put 4 and 3. And then I put 3 and 1/4. Okay? So I know that that looks crazy. That's what they'll actually have you do on the AP exam. What is the formula for the area of a trapezoid? Half the height times the sum of the bases. Don't worry, that comes up a few more times as we review for the AP exam. This is the time in all the other years where people are like, oh, that doesn't seem as familiar. That's kind of a little bit of the new piece. So let's figure that out. I have 1/2 times, what's the first height? 1. And what's the sum of the bases? I can't see it, so I'm trusting you. It's 4. Okay. Plus 1/2 times, what's the next width? 2. What's the sum of the bases? 7. Plus 1/2 times, I think the next width was 3. Sum of the bases? 7. Okay, sorry. So 1/2 times 1 times 1 plus 3. 1/2 times 2 times 3 plus 4. 1/2 times 3 times 3 plus 4. 1/2 times 2 times 3 plus a 4th. That's where we're at. Okay. 1/2 times, what was it? 2 times 3.25. Great. So that's going to be our accumulation. Watch how nicely we can work this through. What's 1/2 of 4? What times 1? plus 1/2 of 2 is times 7 is 7. 3 times 7 is 21. Half of 21. 10.5. Half of 2. So 3.25. So we added up. 2 plus 7 is 9. 19.5. 22.75 inches. That's what we estimate the accumulation to be. Okay? Now, what I want you to do, prepare for the next one, is we're going to go 0 to 6. I want you to see if you and your friends can come up with a left-hand sum. Left-hand sum, three rectangles. Left-hand sum from 0 to 6. See if you can come up with it. Left-hand sum for 3 rectangles. See what you can come up with. Try it on your own. So what you're going to do here, remember, is that your width is 1, right? And the left-hand side, your height is 1.
Yeah.
And then you have width of 2, height of 3. So the first area is 1. The second area is 6. The next area is 3 times 4 is 12.
Oh, so it's not the 4 times 4 plus the 3.
Nope. Because the widths are not the same. So your widths are not the same each time, are they?
You can only do that with width.
Exactly.
Okay.
So I kept it that way all the time on our tests, but the AP exam, they always have the widths different.
So that's what you do.
Yeah. Okay, so part of what people saw is the width the same the whole time? The width is different. What's the width of the first one? It is 1. What's the width of the second one? 2. And the width of the third one? 3. What's the height of the first one? It's left hand. 1 is the height of the first one because it's your left hand. What's the height of the second one? 3, it's the left hand. What's the height of the third one? 4, it's the left hand. So your areas are 1 plus 6 plus 12.
So we disregard the formula.
Remember how we used to do the height times, or the width times some of the heights? Okay? That's because all the widths were the same. I kept it that way for our sake, but when it comes to the AP exam, they will change the widths. So you got to compute each one.
So you got to kind of disregard what you just learned.
No, I would say build off of what you just learned. So we got a 1 by 1, and we've got a 2 by, what was it, 3? And we've got a 3 by a 4. So we've got 1 plus 6 plus 12, which is a total of 17 inches. But read the question. Is that my answer? What is the question asking? Well, that was 19? Oh, dumb me. Is that my answer? Plus 2, why? Yeah, it says the amount of snow on the ground at times 6. So this comes back to what we just did. This is start plus displacement, isn't it? What did we start with? 2 plus the displacement. You just displaced another 19. There's 21 inches. There was already 2 to start, right? Oh, we got used to that. That'll happen. No, there's no doubt that'll be there. Okay? Question?
Like, I don't understand the boxes. Like, why didn't we do that before?
Before in class?
Yeah, I don't ever remember doing that.
Do you remember when we had a function that looked like that? We drew like a left hand or a right hand? That's what we're doing. That's exactly what we're doing. So we'll do the last one together. We end off with this. It says now use a right-hand sum with 4 subintervals. So it's totally okay to have questions on the first couple here. This one should really start to kind of pull through for you. It should start to make sense. Use right-hand sum with 4 subintervals to approximate the average rate of change the snow is accumulating. What is our formula to find the average value for this rate? What's the formula for average value of that function? You remember? 1 over b minus a from a to b of r of t dt. So let's just see what they're doing here. This thing is that's where we say that's the average piece, okay? This thing right here, that's the whole right-hand sum thing that we compute there, okay? So that's what we're trying to do. This is the setup. We've seen this before. We did it yesterday, right? Now it's just a table instead of a function. Well, what is 1 over b minus a? 1 over 8. Now we got to do right-hand sum. Okay, now we've got to do right-hand sum. So I'll draw the rectangles right here. We've got 1, we got 2, we got 3, we got 4. What's the width of the first rectangle? 1. The second one is, third one is, and the fourth one is? Does anybody have questions how I came up with the 1, 2, 3, 2? Okay, so if you look right here, the distance from 0 to 1 is 1. The distance from 1 to 3 is 2.
Okay.
Distance from 3 to 6 is 3. Distance from 6 to 8 is 2. So this tells us our width. These tell us our height. Are we looking at the right hand or the left hand? Right hand. So what's the right hand height here? So we got 3. Change that. So 3 and then 4, 3, 1/4. So those are my rectangles. So I'll put in the area. The area would be 3, 6, 9 and a half. 8. 3 plus 8 plus 9, 20, 20 plus a half. Yeah, so we got 1 over 8 times, so 41 over 2, right? It's 20.5 or 41 over 2, and we get 41 over 16. Inches per second.
It's hours per hour. I just read it wrong.
Hour. Now, just to show you as you check your answer here real quick, how many times does 16 go to 41? It's like 2 point something, right? About like 2.5, something like that. It's asking for the average rate at which the snow is falling. Does 2.5 look like it could be about an average rate? Yeah. So we've said, yeah, that looks reasonable. Okay? So, good job. Way to go. It's a long process. Raise your hand if you've tried at least the first problem on this. Anybody try at least the first problem? Okay, we got about half a dozen people. Okay, might be time to just try a problem or two. I'll be looking for this in about, I would say about 10 days. Okay, so not next Friday, but like the following Monday. It's just 6 problems. 6 problems. 1 problem each page. Okay. Good day to go outside and walk the dog. Wear your hat and mittens, but it's only going to warm up after this.